Here's the problem. This is test 2, this is problem 10C, and what we're finding is we're finding the limit as x tends to infinity of x sine of 1 over x. So first thing we're going to do is we're going to let x tend to infinity, so if we do that, we actually get infinity, and sine and 1 over infinity is 0, so we get sine of infinity, that's 0, and we know that this is an indeterminate form. So since it's indeterminate, then what we want to do is we actually want to go and use L'Hopital's rule. We need to change this into a fraction. So let's write it like this. Let's write it as the limit of sine of 1 over x. Now if I want to take x to the denominator, I've got to write it as 1 over x. And then x tends to infinity. Okay? So now let's see what happens when we plug in infinity. We get sine of 1 over infinity, so that's sine of 0, so that's 0. 1 over infinity is infinity. So now we can actually go and say, okay, let's use L'Hopital's rule. Okay, so using L'Hopital's rule, we say this is equal to the limit as x tends to infinity. Take the derivative of sine of 1 over x. See, here you've got to use the chain rule. So use the chain rule. And if we use the chain rule, then what we get is we get the derivative of sine is cosine of 1 over x, and the derivative of 1 over x, which means x to the negative 1, is negative x to the negative 2, and x to the negative 2 means 1 over x squared. In the denominator, we've got 1 over x, derivative of 1 over x again, that's x to the negative 1, so we get negative x to the negative 2, which means negative 1 over x squared. Now see what happens to these two? They cancel each other out. So this one and this one cancel each other out. The negatives also cancel each other out. So we end up with the limit as x tends to infinity cosine of 1 over x. Let x tend to infinity, we get cosine of 0, and cosine of 0 is just 1. So we get 1. And remember, in the denominator, when you cancel, the only thing that's left is now 1. So we get 1 over 1.